Hello everyone, I'm Matt Kazani from Stroud Research Center. Today I will be showing you the process for collecting grab samples at your sensor station site. Grab sample collecting is an important next step after weekly station maintenance and quarterly sensor quality control have been implemented. The process of sample collecting provides sensor station users a way to analyze the condition of their site beyond the raw sensor data. Through the relationship between field samples and sensor data recorded during the sample periods, we can begin to quantify a rough estimate of sediment amount and salt amount passing by the station on a 5-minute basis. Even better, by combining this relationship with the discharge rating curve equation, the sensor station users can quantify estimates of sediment and salt passing by the station in a single storm, over a monthly basis, and even as an annual total. In order to be efficient with building your grab sample rating curves, the timing for collecting a water sample from the sensor station site should be the most important consideration for sensor station users. Timing should not be dictated by the availability of personnel. Instead, it should be based on the weather and conditions at the station. When a storm is projected to arrive in the near future, a pair of people should plan to be available to go out to sample. These people, or someone in the organization, should monitor the weather forecast routinely and more frequently when a storm is predicted. There are weather websites and apps that can roughly predict the time of day when a storm will arrive and provide radar to geographically track the distance and pace of a nearby storm. As a word of caution, some sites can be dangerous during storm periods. Traveling by vehicle and foot to sensor station sites can also put station visitors into dangerous situations, depending on the route and location. Stroud Research Center always emphasizes field safety over data collecting and does not promote risky actions in the name of science. A trial run for travel to the station, as well as observation of the sensor station site during and after a storm may need to happen before grab sample collecting commences. Stroud's safety department has implemented its own protocol, such as having a field partner, a direct form of communication to headquarters, as well as a sign-out tracking of personnel whereabouts before heading into the field during storm periods. The consideration of safe travel pace and travel delays should be worked into the overall planning phase to limit mistakes and provide stress-free travel. Specifically talking about analyzing turbidity, grab samples should be taken during and after a rainstorm. During these periods, the site will be at its dirtiest from intense runoff within the watershed, as well as from a high volume of water eroding stream banks. The turbidity grab sample rating curve's accuracy is dependent on the number of samples at the middle and upper thresholds of turbidity at the site. Lower end samples near base conditions can still be helpful in keeping the rating curve updated, but time and material should be heavily focused on when the stream is running high and muddy. The timing for taking a grab sample after a storm depends on two things: whether the station is capable of streaming its sensor data online to provide live action updates every 5 minutes, and how quickly the site returns to normal conditions. If your site is offline and you do not know how quickly the site returns to its normal conditions, you should plan to be at the site during the storm or at the very least near the tail end of it. This allows an opportunity to collect a grab sample when the water is muddy. More importantly, you can monitor how quickly the water level drops and the stream clears up. If your site is offline, but you know how quickly conditions return to normal, you should plan to visit the site within the known time frame after the storm has concluded. Try to take multiple samples as the water returns to its base level conditions to quicken the development of your turbidity rating curve. We still encourage someone to be at the site during the storm period to collect samples during peak turbidity periods. If your site sends its data to an online portal, utilize the regular automatic data upload to track current conditions as well as the rate conditions are returning to normal level. Keep in mind that sensors could be fouled from debris and attached particulates, so waiting too long to arrive to the site may waste an opportunity for rating curve development. Specifically talking about analyzing conductivity, grab samples should be taken during snowmelts and during rainstorms in the winter season. When temperatures rise after snowstorms, water from the melting snow will wash salt from roads, sidewalks, and private properties into local streams. When snowstorms transition into rainstorms, the pre-applied road salt will be washed away and into waterways. Sometimes rainstorms will pick up residual road salt from hard surfaces or push salt deposits from storm systems into streams as well. The timing for obtaining grab samples during conductivity spikes depend on the presence of road salt on the roads and hard surfaces local to the site, whether the station is capable of streaming sensor data online to provide live action updates every 5 minutes, and how quickly the site returns to normal conditions. If your site is offline, there is some time lenience during snowmelts. On average, a conductivity spike can last a full day before conditions return to normal, but can last longer and produce higher values depending on land use in the watershed. The slow and incremental addition of salt runoff prolongs the conductivity spike. Multiple samples are encouraged during this period. Spikes during rainstorms are quicker and require someone on site during rain to capture higher end values. Rain provides a higher volume of water and speeds up the rate of runoff. Conductivity spiking can happen quickly, but the decrease back to normal conditions can take more time. Multiple samples are encouraged for this scenario as well. If your site is online, utilize the regular data updates to track current conditions as well as the rate conditions are returning to normal levels. Fouling of conductivity data is not too common, so the values shown should be reliable for field personnel. Performing quarterly quality control checks and regular maintenance will ensure fouling to be a rarity. Supplies should be gathered and prepared ahead of time. Most of the scenarios mentioned are time sensitive and require field techs to be quickly on site and prepared to gather data. Collecting supplies during a turbidity and/or conductivity spike will consume precious minutes of travel. The following supplies will be needed: a 500 milliliter bottle to collect the water sample. Bringing multiple bottles is an option as well. Multiple bottles means multiple water samples within a single visit. This helps to develop the turbidity and conductivity rating curves at a quicker pace than doing one sample per visit. A sticker to label the site name, date, and time when the sample is collected. If taking multiple bottles, bring multiple labels. You only need one label per bottle. Be sure to write in pencil on the label since conditions will be wet. A sensor cleaning brush to clean the sensors before sampling. A watch or cell phone. A field visit data sheet. A cooler to transport the water samples back to a cool environment. And some ice packs to keep the samples cool inside the cooler. Once on site, be sure to fill out the metadata section of the field visit data sheet. If the situation allows and it's safe to do so, take your brush and clean the sensors. Securely attaching a brush to an extendable pole is an alternative method to clean the sensors from the stream bank. This reduces the safety risk of being in the water when depth is high and/or flow is fast. Be sure to record the time of the sensor cleaning. Take a 500 milliliter bottle and move relatively close to the sensors. The idea is to take grab samples close to the sensors. Do not take samples upstream since movement can disturb debris and wash towards sensors, fouling them. It's best to be in stream for grab samples if safe. If conditions are risky, taking a sample from the stream bank just downstream works too. Dip the bottle in the water, cap it, shake it, and pour out the water. Do this 3 times. This prepares the bottle for the actual grab sample and washes out any residue and dirt from the bottle. Dip the bottle into the stream again. Try to go halfway in. Slowly bring the bottle to the surface. As you raise the bottle, turn it so the top breaks the water surface first. Cap it and put a label on it. As a reminder, use a pencil to record the date and time and site name. Pens will become runny in wet conditions. Place the sample into the ice pack filled cooler. Water temperatures can affect the sample's integrity. During cooler times of the year, snow or the stream itself can keep the sample cold on site until it's brought back to your vehicle. With the help of the sample label, fill out the grab sample section of the field visit data sheet. If the site is part of the DRWI network, you should be receiving pre-made labels from Stroud with sample numbers already recorded on them. If not, developing a label system to differentiate samples, especially multiples taken in the same storm, will help with data management as the rating curves are developed more. Be sure to fill out the sensor station maintenance and other information sections of the field visit data sheet before leaving the site. This concludes the process on collecting a grab sample from your site. Remember, timing is key for effectively building the site's rating curves. Sampling a big storm provides opportunity to grab high-range samples. Understanding the length of time a storm can affect the site will inform how quick to be on the site, as well as how long it takes to reach peak conditions. Labeling is another part of the process necessary to build the rating curves. Without labeling, you cannot connect the sample's lab results to the sensor data when the sample is collected. Without the relationship between sample and sensor, a rating curve cannot be creative and further analysis of the site will be difficult. Grab sampling should be a continuous endeavor for the site. Building and refining the rating curves at a quick pace will allow the site analysis to occur sooner. Continual sampling will ensure that the rating curves stay up to date, since all sites are dynamic and can either improve or reduce in water quality. Thank you for watching. I'm Matt Gazandi from Stroud Water Research Center.